Okay, for part two, then, we'll actually take a look at this problem. Let's see. For what value c is the function defined by that? Continuous at x equals -1. Um, well, that we have to... Well, let's explain a little bit. I kind of want to move that. Okay, so for what value of c is this function continuous? Well, first of all, for piecewise functions, they have something and then it switches off to a different type of function and then maybe switches off to another different type of function. So in this case, there are three pieces. That's why, I mean, I made this graph up, but there are three pieces to this function. We are interested in, since all of these are defined, this is just a line, this is just a quadratic, this is just a line. Those are all continuous on their own if they didn't have any conditions. But what we're concerned with is the part where it switches over. Because we have, say, this function, we're concerned with where it switches over to this function. Because if it switches over in a bad way, we could have something like this, right? But we know that our function, we know that, or we want to force this to be continuous, because it's saying what c value will make it continuous. So we're going to look at the x value for which this f function switches from using this to using this. And we're going to take the limit from both sides. And we're going to assume that all three of these conditions are true, and then we're going to find out what c is. Same thing here. We're going to see which x value allows us to switch from this function to this function. And we're going to assume that this function is continuous, so we have to assume that all three of these conditions are met, and then that will allow us to have another equation involving c, and then we'll find out what the c value is. So, this was made up, just to let you know. And what do we got here? What do we got, huh? For what value c is the function defined? Well, so we're concerned with the parts where it switches over, because we don't want this to happen. We actually don't even want that to happen. We want it to be nice, continuous, and everything filled in. So, where does this function switch from, what x value allows us to switch from this function to this function? It looks like -1 is the x value that allows us to switch over. Meaning, like, if I'm on the left side of -1, I use this function. As soon as I hit -1, I have to use this function. And then a little bit onwards, after -1, I have to use this function. Okay, so what I'm going to do is I'm going to assume all of these are true. I'll write them down right now. Now, some people were confused, like, what is it approaching? Well, remember, I'm concerned with the x value for which the f function switches over from here to here. And that x value is -1. So, as x approaches -1, but remember I want to do it from the left side. I'm also going to do it for the right side. And then I'm going to plug in -1. I'm checking all three of these conditions. I'm not checking it. I'm really assuming that these conditions are true. Well, it shouldn't be equals. So, as x approaches -1 from the left side, well, which function should I be using? If x is a tiny bit smaller than -1, then I must take the limit of -x. So that's what I'll put in there. Hopefully that makes sense. And then I use my techniques for solving limits, or for evaluating limits, and that is just direct substitution. So if I plug in a -1, I get a -1, which is just positive uno. Great, cool, that's nice. What about taking the limit? The limit as x approaches -1 from the right side. That means we have to take the limit of that. So same reason. We're plugging in things that are slightly bigger than -1, and that falls into this interval, slightly bigger than -1. That would also, I mean, if it's slightly bigger than -1, then it's also smaller than or equal to -2. So we'll take the limit of -x squared plus x plus c. Just to be clear, when you have a negative x squared like this, that's the same thing as going like that. So the negative is on the outside, just to be clear. Whoops. So what is this? Again, we use direct substitution. Negative 1 squared is just 1, times this negative is negative 1. Sorry, I'll do that in a different color. Negative 1 plus negative 1 plus c. That ends up being, what, negative 2 plus c? Yeah? And we are assuming that those two have to be equal. Okay. Well, let's just, to be redundant, let's see what happens here. If I plug in negative 1, what do I get? I get, well, if I'm plugging in negative 1, this part is equal to, or it says that I can be equal to negative 1, so I'd have to plug it into this, and I would get the same exact thing, negative 2 plus c. So, all three of these, I'm assuming, are equal, because we are assuming that the function is continuous. So that means negative 2 plus c has to equal 1. I'm just going to write it normal. Alright, I'll solve for c. Plus 2, c equals 3. That's nice. But wait a minute, we didn't even use this part. We didn't even use from here to here. Well, let's just write that. 3. The c value that makes this continuous is 3. What if we try the other way? Yeah, let's try it over there. Let's try it for the last two. What can I do? I guess we'll verify the three conditions. Limit as x approaches something from the left side. Well, what am I approaching? What allows me to switch from this function to this function? What x value? It's positive 2, right? Can you see that? Positive 2 allows me to switch. Okay, so 2, that would be, if I'm approaching from the left side, something smaller than 2, I would use that second equation. So negative x squared plus, was it plus x? Yes. Plus c. If I evaluate that, I get 2 squared is 4 times the negative is negative 4. Negative 4 plus 2 plus c, so I get, what, negative 2c? Negative 2 plus c. That's the same thing. Oh my goodness. We're going to get the same stuff. And then the limit as x approaches 2 from the right side, that means we're plugging in things that are a tiny bit bigger than 2, which corresponds to this part of the function. So we'll have to plug in, we'll have to take the limit of 2x. What was it, minus 3? Minus 3. So, what do we get here? Plug in 2, and we get 4 minus 3 is 1. Look at that. We have the exact same equation. So, c will also be 3. That's it for that. Yeah. To be continuous, all three of those conditions have to be satisfied. Hopefully that was understandable. So just make sure those are satisfied. Goodbye.